Hello, and welcome to our crash course on neuroplasticity and its effects on our behavior. Long ago, many people believed that our brains were fixed until adulthood. However, this is not the case as our brains are adaptive and do change throughout our lives. This is similar to how plastic is flexible. Hence, this process of change within our brain is known as neuroplasticity. What is neuroplasticity, you may ask? Does it mean that our brains are made of plastic? Well, of course not. Neuroplasticity is the rewiring of our brain as a result of environmental factors. On the small scale is synaptic plasticity, which is where neurons break connections that aren't used as much to form new ones. On the larger scale, it would be how it forms cortical remapping, which is when brain area X assumes the brain function of brain area Y. Additionally is dendritic branching, which is the making of new synapses. We can thank neuroplasticity for changes in our behavior as well. One way is through our memory, like when we need to memorize new information. Imagine this like developing a picture. For instance, your brain is the film and the images are your memories. Now, every time you take a picture of something, the film needs to retain the image. Our brains work similarly in terms of neuroplasticity, as our brains need to change and rewire to retain new information. Now that we have a general understanding of what neuroplasticity is, let's take a look at a scenario when this gets put to use.
Participants of Maguire were 16 right-handed male London taxi drivers. They each had to go through a training program that would teach them navigational skills in their city, and they were instructed to take many examinations in order to pass for their license. Now, let's look into the life of a London taxi driver and a taxi driver without a car. The study took these taxi drivers from London and used MRI scanning to obtain images of their brains. Those that were too young, below the age of 32, and too old, above the age of 62, were exempted from this test. Each participant was scanned beforehand and were all seen as healthy before MRI scans were made. Then, all of them went through an MRI scan to discover more about their hippocampus. After results were made, they found that there was an increased amount of gray matter in the anterior hippocampus for the control, and there was more brain matter volume in the posterior hippocampus.
These findings helped the researchers conclude that the general volume of the hippocampus had not differed, but the distribution of the matter within different parts of the hippocampus had differed. They concluded that people with more volume in the posterior hippocampus would be more likely to be predisposed to professions that require navigational skills, as most of the participants with these results were taxi drivers.
Well, some of you might be wondering, what was that whole skit for? Well, we just wanted to describe neuroplasticity and its effect on behavior. Neuroplasticity refers to the concept of our brains being able to rewire, make new connections, or break old connections in response to learning new things. With the study of the taxi drivers, it was observed how their brains take on a slightly different form when compared to similar people. What we mean by this is when we compare 40-year-old taxi drivers to 40-year-old office workers, making the difference that the taxi drivers have an extensive knowledge of the roadways. The comparison of the brains gave insight on the different areas of concentration depending on what they are observing. The taxi driver showed a difference in the redistribution of gray matter in the hippocampus, showing how neural connections are built depending on the information being absorbed.